previous video, we studied that sound needs a medium for propagation. That is, it requires some medium to travel from one place to another. But how does it really travel through the medium? What happens to the particles of the medium? Let us find out. We now know that sound is produced by vibration. When the object is vibrating, it sets the particles of the medium around into vibration. In the process, the nearest particles to the source gets displaced from their mean or equilibrium position. They start to collide with the particles adjacent to them. The adjacent particles then also get displaced from their mean positions. They in turn do the same to their neighboring particles. This process continues in the medium till the sound reaches our ear. We see that we create some disturbance flowing through the medium. This is the way that sound travels through the medium. We see that particles of the medium are not traveling from the source to the human ear. It is the disturbance produced by a source which is traveling in the medium. The particles are merely oscillating from their mean positions. This disturbance created by the vibrating object in the medium is what we call a sound wave. But what does this disturbance look like? Let us study this with the help of a tuning fork. Here we take air as a medium of propagation. Here we have a tuning fork made up of steel. This shows the initial condition of the air particles of the medium when the tuning fork is in its original position, that is, when tuning fork is not vibrating. When we strike its prong on a rubber band, we start hearing a sound. How does the sound travel through the medium? The two prongs of tuning fork are vibrating. Let us concentrate on motion of one of the prongs first. Say the one on the right. When it's away from its mean position, it pushes and compresses the air particles around it. This creates a high pressure region, also called compression. This compression travels in the medium as a disturbance. Here the density is high. That is, the particles are very close to each other. When the prong comes towards its mean position, the pressure on the right decreases and keeps on decreasing further as the prong continues its motion towards left. This creates a low pressure region, also called as rarefaction. We see that at this point, the compression in the form of disturbance has reached this region. This rarefaction also travels in the medium as a disturbance. Here the density of particles is less. That is, the particles are far away from each other. As it continues to vibrate, we get a series of these compressions and rarefactions. This continuous sequence of compressions and rarefactions is what we call sound waves. Yes, the sound waves travel in the form of compressions and rarefactions. Instead of the tuning fork, if we take any other source of sound, say the speaker, then the sound waves generated by this object will also travel in the form of compressions and rarefactions. Here is one interesting question. Is the sound wave a mechanical wave? Do you know what a mechanical wave is? The mechanical wave is a wave that requires some material medium to travel. And as we know, a sound wave also requires some medium to travel. So yes, it is a mechanical wave. How do you define vacuum? Can sound travel through it? To find the answer to these questions, you have to wait for our next video. See you there.